Hi, everyone. This is Dr. Bate, and this is the project management lecture for the course. Um, Oftentimes in class, when we're talking about project management or with students, students seem to say, hey, you know what, I've never managed a project, but I would disagree. Um, I think that we need to think about project management in all aspects of life. Think about some of your own experiences in managing projects that could have been personal, household projects, work projects, life projects. It all follows the same systematic approach. What was the scope? What were the problems encountered? What type of management policies and techniques were used? Were any incentives offered to anybody, team members, family members, friends, to complete the tasks effectively? And were those incentives attached to the project as a whole or to specific tasks? What is a project? Oftentimes we get confused with projects and processes. Processes are continuous, whereas a project is a series of related tasks or jobs usually directed towards some major output and requiring a significant period of time to perform. So in a project, you have a start date and a finish date, and it ends, whereas processes within an operation are continuous tasks that occur on a routine basis. Project management is the project is planning, directing, and controlling the resources, people, equipment, and material to meet the goals of the project, whether they're technical, cost, and time constraints. So we know that general management techniques that you learn also apply to projects. Why is project management important? Often at the highest levels of an organization, management involves juggling a portfolio of projects. There's often lots of different projects going on at one time, and industry has found that having specialized project managers with expertise in managing the world of projects has been very fruitful and proven to be worthwhile. Skill sets of project managers is where that expertise comes into play. You know, as a project manager, you're not just dealing with the technical aspects, such as those that are working on the engineering or the design or the implementation of a project, that are actually doing the tasks that speak in a very technical language, which you should be aware of. You also are working with the higher ups who don't want to get bogged down with all of those details when asking for an update, and kind of want a high level overview of accomplishments, of what problems are encountered and how those are going to be fixed. So as a project manager, you have to be able to bounce back and forth between the technical and the non-technical side, be able to speak low level, be able to speak high level, and be able to do that effectively and efficiently. One of the popular one of the reasons why project management is so popular is because the skill sets that are utilized in project management can be applied across all industries. It's not just specific to one specific industry, whether it's in the hospital and healthcare field, whether it's in engineering, whether it's in construction, whether it's in IT, whatever. Okay, the PMP certification is a universal project management certification that it can be obtained by project managers through the Project Management Institute, and you'll find that PMPs are located across all different types of industries. So it's a pretty interesting field to be in. Defining a project. When we look at a project and we start to say, okay, we want to get started. Basically, we start out with a statement of work or a scope document, written description of all the objectives that we want to achieve. Following that, we list out all of the tasks, okay, all of the tasks and activities that we want to achieve, and then we put them together in a work package. Then we establish milestones, and we finally create a work breakdown structure. Work breakdown structure is what we'll aim for. Think of your syllabus as a work breakdown structure. It has a timeline of all tasks that need to be completed, okay, the due date, okay, and you could also estimate how long each task could take to complete, whether it's 1 week or 2 weeks. When looking at a work breakdown structure, we like to, at the minimum, include the following: activities, okay, the duration of the activity, the start and finish time, and predecessors. Okay? Activities are the tasks that need to be completed. The duration would be how long the task is expected to complete. So we use an estimated time formula in order to estimate duration. Using optimistic time, okay, the best case scenario, whether that's 3 days, 2 days, 4 days, the most likely time that we expect the task to be completed in pessimistic time, the worst case scenario, we input that into the OT plus 4 times MLT plus PT divided by 6 formula, which would give us a timeline that would incorporate a time that would incorporate optimistic, most likely, and pessimistic, and that would be what we could use for our duration. Calculating the start and finish time is a complex formula that it's unnecessary to do by hand. Project management software such as Microsoft Project will automatically calculate those for you once you enter in the duration. And predecessors. Predecessors are which tasks have to be completed before another task can be completed. So if we've got task A, B, C, and D, once we input those activities and we input the duration into our project management software, our software is just going to assume that they can all be started at once at the same time. Well, we know that that's not the case. We know that we may need to complete A before B can be started, or we may need to complete B before D can be started. So we need to input those predecessors. Which tasks have to be completed before the other tasks can be started? Once we input those, our start and finish times start to change. Thinking about the critical path method for planning. A project is made up of a sequence of activities that form a network representing a project. The critical path is the path taking the longest time through this network of activities. Provides a useful, very, 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 very useful wide range of scheduling information when we're managing a project. Identifying a critical path, okay? Each activity to be done and estimate how long it will take has to be completed first. Then we determine the sequence of activities and construct a network diagram, and then determine the critical path. Project management software can determine which activities are critical for us if we are inputting those in. Otherwise, we can look at how we do this by hand. So let's say that we have task number A, C, B, D, E, F, G. And we draw this out and say that task A is 21 days, task C is 7 days, 5 days, and so forth. We've input here in our diagram, okay, don't pay attention to any of the markings yet, but you can see how our predecessors are set. A is connected to C, so C can't be started until A is completed. B can't be started until A is completed, but C and B are not reliant on each other at all. It seems very simple, but in order to determine the critical path, all we do is look for the longest way, look at the various routes to be able to get from, okay, A to G. So we know that we could just kind of draw a line from here, here, from A, B, D, E, and G. We know we could go A, B, D, F, G, A, C, E, G. Okay, lots of different routes. We take those routes and we calculate the duration based upon the number of days that we know the tasks are going to take to complete, and we come up with our critical path. When we tally those paths up, whichever path has the longest amount of days is the path that we'll consider to be critical. In this case, the two paths that are long are equal in 38 days. So we have two critical paths. Now, what does this tell us as a manager? The critical path is important because now we know which tasks cannot be delayed without extending the length of the project. We could use this critical path now to estimate that the length of the project would take 38 days. Because we've taken the longest path, okay, we know that anything that is on the path, any letter like C that is on the path that is critical, we know if that changes and gets delayed from 7 to 8, that the 38 changes from 38 to 39. Okay, but we also know that any tasks not on the critical path, okay, can be delayed. And since they weren't included in our calculation for the 38, it can go a day or two without increasing the length of the project. So tasks that are critical, okay, that are on the critical path, we know can't be delayed without extending the length of the project. From a managerial perspective, that's important to know when we're looking to stay on time. We know that tasks not on the critical path can be extended. We call that having slack. Tasks that have slack, okay, we would calculate in our project management software exactly how much slack they have. We know that perhaps we have an extra couple of days for task B without extending the length of the 38 days. That's also important to know when planning out resources. Also, we want to be able to give clients the longest period. That way we have, even if we finish early, at least we've bought ourselves some times and we're managing expectations. As well, oftentimes there are clauses put in the contracts for project managers to get bonuses by finishing early. So we definitely want to know what that critical path is and give the longest duration estimate for the project, and also know what tasks we need to manage more carefully to make sure that they don't get delayed so that we can finish and get our bonus. Crashing. Crashing is an interesting part of project management, and we always want to be able to make a determination on whether or not we crash. Okay, when we say that an activity will take a certain number of days or weeks, what we really mean is that this activity normally takes those amount of days or weeks. We could make it take less time, but to do so would cost more money.